Today's notes are on adding and subtracting polynomials. And a polynomial is just an algebraic expression that has many terms. And we have to keep in mind that terms are separated by addition or subtraction. So that's really important for you to remember. And there are different kinds of polynomials. A monomial only has one term. Binomial has two terms. And then there's also trinomials, which have three terms. And that's the ones that we'll be dealing with while we're doing this lesson. We're also going to talk about the degrees of polynomials, and the degree is the greatest exponents of any one term. So I'll show you that here in a second when we get ready to look at that example. We'll also be adding and subtracting polynomials today, and remember that we can only add and subtract like terms. That means that like terms, remember, have to have the same variable and also the same exponent to be able to add and subtract those. So let's take a look at our examples here. So on the first 5 problems that you'll have on your homework, you're going to determine the degree of the polynomial, whether it's a monomial, a binomial, or a trinomial, or neither. And then you're also going to determine the degree of the polynomial. So on this first one, remember the first thing we need to do is separate this thing into terms. So every time you see a plus or a minus sign, that separates the terms. So negative 4z to the 6th is a term, 8zy is a term, and positive 3z squared y is also another term. So this problem has 3 terms, so that makes it a trinomial. That's the kind of polynomial that it is. So that's the trinomial, so we've got that part, the type of polynomial that it is. The second thing we want to do is determine the degree of the polynomial. So what we're going to do is take each term and we're going to add the exponents on the variables. So on this first term, negative 4zy to the 6th, the z has an exponent of 1, the y has an exponent of 6, so that one would have an exponent of, or a degree of 7. On the next term, the z has an exponent of 1, the y has an exponent of 1, so that has a degree of 2. On the third term, the z has an exponent of 2, the y has an exponent of 1, and so that degree is 3. The degree of the entire polynomial is the one that's the biggest, so it's a 7th degree polynomial. So that would be your answer for that. Okay, let's go on to adding and subtracting polynomials. Again, the biggest thing to remember is that you can only add and subtract like terms. Before we get to that, we're also going to do some problems where we actually have to substitute numbers that they give us into equations. So in number 7, they give us an equation right here, or an expression, negative 16t squared plus 1,160. And they're telling us that the height of the object, they want us to find the height of the object when t is 1 second. So all we've got to do is substitute 1 in place of the t. So 1 squared is 1, and negative 16 times 1 is negative 16. And negative 16 plus 1,160 is 1,140 feet. So the height of the object after 1 second is 1,144 feet. Okay, now we're ready to add and subtract our polynomials. So we'll go ahead and scroll down here to number 11. And the first thing you've got to do is find your like terms. And remember that like terms have to have the same variable, and they also have to have the same exponent. So on this first one, I have 1/6 x squared, and it's like this x squared, and that x squared has a 1 in front of it. So those two are like terms. So 1/6 x squared plus 1x squared is 1 and 1/6 x squared. If I add those two coefficients together. Then I also have -1/4 x to the third and -1/3 x to the third. Both of those have the same variable, x, and the same exponent, 3. So when I do -1/4 plus -1/3, that is -3/12 plus 4/12, that's 7/12 x to the third. And this positive 16, there's nothing that's like it, so I'm just going to drop it down, plus 16. Now, anytime you're writing a polynomial, they'll want you to put the term that has the biggest exponents first. So this term has the biggest exponent, so that we're going to put that first. So -7/12 x to the third. Then I would put this one next, plus 1 and 1/6 x to the second, and then plus 16. So that's the correct order. And there's nothing else that I can do with that problem, so that's the answer. On number 12, finding our like terms, -7a squared and -4a squared are alike. That makes -11a squared. Then -6ab and -6ab make -12ab. And then +5b squared and +9b squared make +14b squared. And so that is our answer. -11a squared minus 12ab plus 14b squared. Okay, let's go ahead and go to the next page and do our other examples. Okay, on number 16, we've added some parentheses in here. Anytime you have parentheses, you might want to remind yourself that you need to distribute. So because I don't see a number in front of those, I'm going to put 1s in front of them. Do that one. Kind of blended in with my parentheses, so it's a -1 right there. So I'm going to distribute with a +1 on this one. So it would be 9y squared plus 7y minus 2. Here I'm going to distribute with a -1. So -1 times -5 is +5y. -1 times +7 is a -7. Now I'm ready to find my like terms. There's nothing that's like the 9y squared, but the 7y and the 5y make 12y. The -2 and the -7, when I add those together, that makes -9. And then I just drop down the 9y squared. And we are going in order of our exponents. The 2 is the biggest one, so we'll put that one first. On number 17, we've given us a word problem here that says subtract 7x plus 12 from the sum of 5x plus 6 and 8x plus 5. Anytime you see the word subtract from, this part needs to go at the end of the problem, because we're subtracting 7x plus 12 from all of this part. So that's going to go at the front of the problem. Sum means that I need to add these two. So I'm going to write this problem as 5x plus 6 plus 8x plus 5, and then subtract is 7x plus 12. Notice that I kept everything in parentheses because that tells me that I need to distribute. That's not as critical on the positives, but on this negative, it's very critical. So 1 times 5x is 5x, 1 times 6 is 6. 1 times 8x is 8x, 1 times 5 is 5. Negative 1 times 7x is negative 7x, negative 1 times 12 is negative 12. Now I'm ready to simplify this by adding my like terms. 5x plus 8x minus 7x. 5x plus 8x is 13x, minus 7x is 6x. 6 plus 5 minus 12. 6 plus 5 is 11, minus 12 is negative 1. So the answer, or the simplified version of this polynomial, is 6x minus 1. These are all expressions. There's no equal sign, so we cannot solve these problems. We can only simplify them. Now let's move on to number 19. Very similar to the one we just did. So I'm going to be subtracting 5x from 7x minus 3. So the 5x needs to go at the end. So I've got 7x minus 3 and then minus 5x. So my like terms are 7x minus 5x, which makes 2x, and then just drop down the negative 3 because there's not another term that's like that one. So that one was pretty simple. All right, and finishing this up, number 21. Number 21 says that a wooden beam is 6y squared plus 5y plus 1 meters long. If a piece of length y squared minus 11 is cut, express the length of the remaining piece. So if I'm going to cut this part out of the beam, that would mean I would take the whole thing and subtract the part that I cut out. So the problem that I need to do is 6y squared plus 5y plus 1, and I need to subtract out y squared minus 11. Notice I kept those in parentheses. So putting ones in front of my parentheses, I'll distribute. 6y squared plus 5y plus 1. I just multiplied each one of those by 1. Here I'm multiplying by negative 1, so negative 1 times y squared is negative 1y squared. Negative 1 times negative 11 is positive 11. Then I'll find my like terms. 6y squared minus 1y squared is 5y squared. There's nothing that's like the 5y, so I'm just going to drop it down. And then I've got positive 1 and positive 11, which makes positive 12. So this expression is simplified because there are not any other like terms. Really, benchmark 2 and benchmark 3 of this project are to get you ready for the last project we'll do this year, which is to build rockets. And we will be solving polynomials that are in this form. They're called quadratic equations. And we will be able to solve those by the end of this year. So benchmark 2 and benchmark 3 are really setting you up to be able to do that project.